Hi, so today we're going to talk about polynomials and in behavior. The first thing we're going to do is write each polynomial in standard form. If you're wondering, standard form means descending exponent order. So the highest exponent followed by the next highest, all the way down to x to the 0, which will just be any sort of constants. So let's first deal with this one. X squared plus x cubed minus 9. So if you look here, the big thing that needs to happen is this needs to jump up to the front. So x cubed plus x squared minus 9. All right, let's look at our next one. In this case, what we have to do is distribute. 3a times a cubed ends up being 3a to the 5th. Remember, if I multiply two variables that have an exponent, we add the exponent if they're the same variable. So now let's do the next part. The next part is 3a times negative 4 becomes minus 12a squared. Sorry about that. Minus 2. All right, so that's standard form. Now we're going to talk about this. Polynomials can be classified or grouped according to the number of terms it has and according to the degree. So if we have a 0 degree, that's the same as saying something like x to the 0. And x to the 0 is just a constant because x to the 0 is 1. So if, for instance, we had 3x to the 0, that would just become 3. So now that we have 3, let's look at how many terms we have. There's only one term, because that's all you can have with a constant, and its name is a monomial. So because we have a constant that is only one term, that is a constant monomial. Now, a polynomial could also be with 1 degree. That's x to the 1st. But whenever we have something like x to the 1st, we might as well just say x. And something like x plus 7 would be known as a linear equation. So here's an example of a linear equation, x minus 2. So let's see how many terms we have here. We have 2 terms. And the name of a 2-term is a binomial, meaning this is a linear binomial. All right, let's talk about what happens when our degree is second degree. In this case, we call that a quadratic. You should remember this, seriously. We've talked about it how much? Remember this. Please remember this. So, here's an example of a quadratic. Now, you might be going, couldn't it be 3 terms? That's what I thought was going to come next. And it could. I could have said plus 7. But it doesn't have to be. We could have a quadratic monomial, just x squared. There are so many different options on this. But in this case, we have a quadratic. And how many terms do we have? Only 2, meaning it is once again a binomial. Or more accurately, a quadratic binomial. Now let's talk about what happens with the third degree. So, in this case, the third degree means that we call it, well, let's see. To the third degree is called cubed, and it's called cubic. Here's an example. All right. I am sorry. So, let's see how many terms we have in this case. There are 1, 2, 3. 3 terms. And when we have 3 terms, we call it a trinomial, like tricycle. Just like binomial is like bicycle, or triceratops, or many other things, and all the time tri means 3. So, a trident has 3 points. Now, this would be a cubic trinomial. Now let's talk about the 4th degree. When we have the 4th degree, I want you to think of like, 4 of what coin equals $1, and that's a quarter. And much like that, this is a quartic term. So here's an example of a quartic term. Notice we could have had a 5th term right here. It would have gone right in there in between the 4, x to the 4th, and the x squared. But in this case, we don't have it. So there are 4 terms. And for us, whenever we only have 4 terms, we're going to use this as the name, polynomial with 4 terms. Meaning this is a quartic polynomial with 4 terms. Now we only have one more thing, if the degree is 5. If the degree is 5, the name that we use is quintic. Here's an example of a quintic equation. 3x to the 5th. Now, how many terms are there this time? Only one again, which means it's a monomial, or more specifically, a quintic monomial. All right, so let's classify each polygon by the degrees and the number of terms. So we're going to start with this one. First thing, it's to the 4th degree, which means quartic. And there are 1, 2. There are 2, which means binomial. Now let's try this one. Ooh, notice that we're subtracting. So 3x squared minus x squared ends up being 2x squared. Now the next part, negative 4x minus, so that's plus 4x, those are going to cancel out. And 1 minus 1, those also cancel out, meaning we just have a quadratic monomial. All right, let's look at the next one. So if we're trying to find a cubic model, the way we tend to do it is in a calculator. So you go to Stat, and in the Edit bar, under L1, you would just put in your x values. -2, -1, 0, 1, and 2. In L2, we put our y values. So that's -7, 0, 1, 2, and of course 9. Then I press Calc and then cubic reg, and we end up getting our answer. Our answer in this case, x cubed plus 1. All right, so now we're going to talk about end behavior in polynomials. So here's an equation. First off, what we have to understand is the behavior of the graph f of x as it approaches positive or negative infinity. What that really means is basically, what is the graph doing? Is it going up or down as I go to the right and as I go to the left? The degree of the leading coefficient of a polynomial and the degree and the leading coefficient of a polynomial function determine this in behavior. So let's start with this one. Our leading coefficient is 3, which is positive. So what that tells me is my end behavior on this one is going to be going up. When it's positive, it always goes up on the right. But my degree is 4. So because 4 is an even number, that means it's also going to go up on the left. Now let's try another one. In this case, my leading coefficient is -2, which means it's negative, meaning it goes down on the right. But my degree is 2, which is even. Now, this isn't always the case, but at least for now, if the degree is 2, what we're going to find is the end behavior, it's going down. Here's the next one, 2x cubed minus 9. So what's our leading coefficient here? It's 2, which is positive. That means going up. But the degree in this case is 3, which is odd. And when it's odd, that means that we go the opposite direction on the other side. So down, then up. Now let's talk about this one. In this case, -1 is our leading coefficient, which is of course negative, which means it goes down on the right. But because the degree is 5, that's odd. That means on the left, it goes up. So let's try this. We're going to determine the end behavior of the following polynomials and sketch a basic graph. So let's see. I'm going to say the leading coefficient is negative, and that means it goes down, but the degree is 5, which means it goes up then down. So if I'm graphing this, I'm going to start by being higher up, but then I'm going to need to have 4 turns because the degree is 5. So 1, 2, 3, 4 turns. There we are. And this is what the graph would look like. All right, let's try this one. In this case, the leading coefficient is positive, meaning going up, but the degree is 4, meaning it also goes up on the left. When I graph, I need to have 3 bumps, so 1, 2, 3, there we are. All right, we're now going to identify whether the following graphs have an odd or even degree and a positive or negative leading coefficient. So to find out if it's odd or even, I notice that the sides, both edges, are going the same direction. That means even. But since that direction is down, it also means negative. Let's look at the next one. Notice that they are going opposite directions on this line. One is going up, one is going down. That means odd. Now, since on the right side it's going down, that means negative. Finally, this one, different directions again, down and then up, but since on the right side it's up, that is an odd, that is positive. All right, we're going to do some key attributes now, and that'll be it for this lesson. So, what is the end behavior of g of x? Well, let's see. It's negative, leading coefficient, and it is even, which means since it's even and negative, it's going to go down and then down. What is the x-intercept of the graph if it's y equals g of x minus 3? So g of x minus 3 means y equals negative x minus 3 to the fourth. So let's see, if I want y to be 0, what number gets me 0? What minus 3? That's right, x has to equal 3. What is the y-intercept? So let's see, when x is 0, that's negative 0 to the fourth. That means y is 0. What is the domain? Well, because there are no restrictions on the domain going left or right, it will just go on forever. It is negative infinity to positive infinity. All right, now we're going to talk about transformations and key attributes. So we're going from x cubed to 3x cubed plus 2. What's the behavior of h of x? Well, to be honest, you do have to check this just to make sure it stays positive or if it goes negative. This is more important when you have a number that is negative. But in this case, this would be the same as saying 27x cubed plus 2. Well, we have a positive number, meaning on the right side it goes down, but on the left side it is going to go up because we have an odd number for our degree. So how is x being translated? The translation is just the plus 2, which is a vertical shift up 2. Now, what is the y-intercept of h of x? Well, let's see. When I multiply it, if I make x 0, this part cancels out, leaving us just y equals 2. What is the domain of h of x? Negative infinity to infinity. And how is h of x being stretched or compressed? That's where we deal with this part. Now remember, because this is part of the function, it's inside the transformation, inside the parent function, I'm going to say that this is horizontal. Also, because it is a number greater than 1, I'm going to say it is a compression by a factor of 1/3. And that's it for today's lesson. Thank you all very much. I hope that you all had a good time. We'll see you again soon. Have a good day.